G'day, Stephen Barter here. How are you doing on this great day? Me, well, I'm still excited because I've got another fantastic lesson here today. And it's one of those lessons again where I'm a little bit complex, a little bit confused about because I don't understand how so many moulding shops have also not understood this information. It's vital information, stuff that you need to know and is actually going to solve you a lot of problems. So yes, I'm still a little bit confused, but I'm damn excited and I can't wait for you to enjoy this lesson. Okay guys, so here we are, Module 2 in ProMold Professional. Today we're going to talk about the mould, or continue on with the theme that the blow mould is a heat exchanger. But today we're going to particularly talk about the Parison melt temperature. So just quickly before I go on, I'm going to start with a definition. So the Parison in my words, or in my world, is the molten plastic extruded tube in extrusion blow moulding. So lots of different definitions or words used for the same thing, but throughout this course, the Parison means the extruded tube. Now, a little bit more housekeeping. Every machine and situation is different, so this information is recommended based on real experiences and best practices. All responsibilities is with the operator conducting business. What does that mean? So basically what it means is I'm giving you advice and steering you in a direction that has worked for me time and time again. So what I put here in these modules is proven. It's best practice. It works exceptionally well for me, and it has over and over again. But I don't know your situations. I don't know what's going on with your machines. I don't know what else is in or out of control within your business. So it's very important that you're aware of what's going on around you before you go and making any changes. Okay, so in Module 1 we talked about the water cooling. So I'm hoping you remember that we talked about this little guy over here. Tonight we're going to talk about this one. So we talked about air pressure, or very briefly. We haven't covered that off as a topic yet, but we did talk about the water pressure and water temperature as part of that cooling process. And I just thought I'd share with you down below in the bottom of this page, there's a thermal image. This was of a 20-litre container. And fault finding the process, you can see around here the white and red represents very, very hot, and as the product cools, so these photos were taken in I think 30-second intervals from memory with a thermal imaging camera. Very, very powerful tool. I'd suggest if you can get your hands on one, do so. So you can see where the hot spots, or in this particular product, are. So we'd be looking at things like water cooling in around the neck and the handle. We might be looking at how much plastic's in there. We've got to check the air pressure, make sure we've got the right amount of air pressure there as well. So, the last episode or last module was really, really important. Please do not progress until you have done all those activities on at least one machine mold setup. I cannot stipulate how important it is for you guys to do that. If you don't do it, if you skip it, you're not going to get the benefit. And what we talk about tonight it won't help you anywhere near to the degree as what it can do. Okay, so if you haven't done your homework, please stop this module, go back and do your homework, and you can always come back to this one later on. Okay, so today is all about Parison melt temperature. Now, first of all, I'm just going to touch base on what actually controls the melt temperature when everything is working properly. So looking at these three pictures here, I'll just start on the top one there. We've got this is an extruder element, so it's got a cover on it. So there's a couple of components to it. There's the element itself. Now, obviously they come with the machine manufacturer, so we don't need to get too much into that detail, but what we've got to do is make sure the element is working properly. The thermocouple is working properly, and in this particular case we're using a cooling fan to control overrun of temperature. So you're going to need an electrician to test all of those. Now, what's really important is that you make sure you do test those. We don't want to assume that things are working correctly. If we do that, we could be battling problems we don't know we have exist. So it's always a good starting point when you're developing a new product in particular, is to make sure the foundations are correct. You want that temperature of your Parison to be exactly what you need it to be. And if it's not, then you could be chasing your tail making mold modifications. So remember, the mold is a heat exchanger. So if we go and put excessive heat or overheated temperatures into our Parisons, and then we put that into a mold, then we're going to get the wrong results. And the last thing we want to be doing is modifying molds to get that. So what are some of the things that could actually go wrong here? For example, the thermocouples. I've seen simple cases where the contact point of the thermocouple wasn't connected properly. Loose connections, loose wires. I've even seen extreme cases where an OEM, original equipment manufacturer, has actually installed the wrong type of thermocouple. What this meant is the machine was reading, I think it was something like 70 or 80 degrees Celsius below its required set point. Very, very dangerous situation. That customer was lucky they did not snap that extruder. So we've got to make sure the thermocouples are working properly, the contact points are working properly, there's no damage. You could also have situations where maybe something's gone wrong and somebody's been working on your machine and they've actually plugged the thermocouple into the wrong location. So getting your electrician to test everything. Don't just accept an answer that, yep, should be right. It's got to be checked and make sure everything's working correctly. With your heater elements themselves, you could have faulty relays. Now, a welded relay in older machines or a damaged solid state relay, they can actually get a temperature controller to just constantly drive heat. So again, only an electrician can tell you whether you've got a problem or not. So what I do insist that you do is make sure that you check and fix any issues before you're starting up. If you don't have the right foundation, you're never going to be able to achieve your end goal. So some of the things that we might see with, for example, a Parison, an extrusion system that's not working properly, is we might see an increase in shear heat. Now, shear heat will cause variations in your Parison temperature. As a result of that, variations in your product quality. But also, it can actually change quite a bit when you change your resin mix. So, still talking about high density polyethylene. But if you change the ratio of regrind in there and you've got temperature problems, you're just going to compound that. So, every time you make an adjustment to your regrind add rates, any temperature issues that you have in your machine are going to send your process out of control. The other thing I want to touch on is the Parison profile. Now, this particular screen here, this is for a Uniloy machine. It was for a machine that had multiple extruders. So you can see we've got a nice consistent profile. We don't want to have a profile that's up and down all over the place. I would generally run a profile with no more than 15 degrees range from the hottest to the coldest point. So I want to make sure that temperatures are working properly. I want to make sure that I've got a nice consistent profile. Otherwise, I'm going to get variation. Now, down the bottom of this screen down here, you can see an example of a machine where things haven't quite been working right. You can see set points are all over the place. There's temperatures that are really high, temperatures that are really low. This is systematic of a real issue that needs to be dealt with immediately. If you see this in your machine is out of control, you're at risk of damaging the machine, but also you're at high risk of making reject product. So don't accept no for an answer. Make sure all of your machines are working properly. So one thing you might want to do, and I like to do when I'm starting up an extruder, I have a handheld digital laser temperature controller, which works very, very well on plastic. So all I do is point this little laser temperature reader to the Parison when I first start the extruder. So if you can imagine you've had the extruder turned off for a little while, the machine's just sitting idle, and then you turn the extruder on, and the first couple of inches of plastic that comes out of that extruder is going to be resonant temperature for the extrusion head. So if you measure that, and you'll find that it's a lot higher than the set point or a lot lower than the set points for the head, straight away that's going to tell you that you've got a problem. and then you need to go back and check your elements, your thermocouples, your temperature controllers. Okay, just on the temperature controllers, I haven't touched on those ones. They're very basic. It's like any other computer. It can only do certain things in a certain way, in a certain manner. If it's getting poor quality information coming into it, for example, a damaged thermocouple, then it's going to send poor quality information out to the heater element. So your process will be out of control. Okay, so let's talk about molding a single Parison. So why is it so important that we have optimum temperature control for a Parison? So what happens when you extrude your Parison? If the temperature is correct, then it's going to blow into the mold shape correctly. If it's not, you've got variations in temperatures. You're going to see paneling, you're going to see sink marks on your bottle, you're going to see base rock. The base would be distorted because the base is typically the hottest part of the molding when the mold opens. So you're going to see a constant variation in weight, you're going to see a constant variation in wall thickness, top load, and anything else associated with a Parison that is out of control. So it's really important that we take that first step and make sure everything is in control. If the Parison is too cold, then we're going to get melt fracture on the surface of the Parison. And that's like a really rough, scaly finish. Now, with that scaly finish as an indicator, it'll also tell you that you're going to have quality issues. Of course, poor texture on the bottle, but you're going to have splitting drop tests. So the welds will not weld together. So in this particular case, we've got a 2 litre bottle there. If the temperature was too cold and I dropped that bottle from, say, 1.2 metres, then it would split quite aggressively as well. So the too cold also means that I'm going to create some surge in my extrusion. So my extruder is rotating at a constant speed, but because of the shear heat that's going to be generated from being too cold, the Parison is going to accelerate, slow down, accelerate, slow down. So with your wall thickness controller, that's going to change the positioning where it meets the mold, where it meets the bottle. Therefore, your weights are going to go up and down, and you're going to have top load issues. So lots of weight variation, top load issues, drop test failures, or from being too cold. Now, what about on the flip side? What happens if it's too hot? Well, the obvious thing is, you're going to have longer cycle times because the plastic's going to be going into the mold a lot hotter. But it's also going to create very thin welds. So why would it create thin welds? Well, I'm going to I'll touch on it just very, very briefly, but where we have a molding and we have vents down the side, so as the air is trying to escape through the mold vent down the side of a bottle, the plastic Parison is expanding with the air being blown up by the blowpin. Well, because it's so soft from being so hot, it'll actually mold around the air that is trapped inside the mold and is trying to get out through the vent. So what that means is the Parison molds around air, its pressure is increased inside, and the pressure on the outside is increased, it's like a diaphragm. So the plastic molds around that air pocket. Eventually that air pocket will bleed out, but the problem is the Parison's already molded around it. It's already created a thin stream down the side of the bottle. Now what that means is, again, you're going to see a very faint window along the part line of the bottle. It's going to create drop test issues for you, so the bottles may split. Now the other thing is, you can see the word here I've used, draw. So when we expand the Parison into the mold shape, into that draw, anywhere where we've got a corner, for example, the base corners on this bottle, if the Parison's too hot, plastic will stretch too easy. And as a Parison is inflating in a mold, the Parison will, as it touches the mold surface, it stops moving. Now if it's too hot, the plastic will just thin straight down, and into those corners you'll have really, really thin corners. So again, we've just got to make sure we've got our temperature right. We don't want to go and turn the temperature down just because we've got thin corners on a bottle. What we've got to do is physically check the Parison temperature. Okay, so again, if it's too cold, you're going to have quality issues, you're going to have machine issues, and if it's too hot, you're definitely going to have quality issues, you're definitely going to have machine issues, but you're also going to have a longer cycle time. Now let's look at the situation where we have multiple Parisons. Now this gets quite complex. So I'll go through here. You can see a photo there of a setup. It's a triple head. We've got temperatures all over the shop. In this particular case, you can see the temperatures are out of control. We've got one high, one low. So who knows what's going on within that extruder and that extrusion head. So the plastic, when it's too hot, for example, will flow it a lot easier. It'll also expand differently into the mold, as we mentioned earlier. But it'll also expand differently and behave differently when you start adding support air into your Parison. So in this case, this particular Parison here was hotter than the other guys. So that means when I put a tiny amount of support air in there, it's actually going to react quite aggressively because there's no resistance to that pressure coming internally of the Parison. It just blows up like a balloon. So I've got to make sure that the Parison temperatures on multiple heads are all exactly the same. So if I don't, each of these Parisons are going to behave differently. Now, what will quite often happen is people will adjust the individual Parison temperatures to try and get the length the same. Now, this is a big mistake. Again, taking a step back and thinking about how the Parison inflates in the mold. If we've got different temperatures on the same mold, going into the different temperature Parisons going into the same mold, we're actually going to get a very different result. We're going to get the different weights. We're going to get different thin and thick corners. We're going to have some bottles taking a lot longer to cool down than others. So it's going to affect every quality problem that you can think of is going to be influenced by having variable plastic temperatures between Parisons. So we've got to get that right. Now, how do we get that right? First things first, we've got to make sure that we get all those temperatures the same. Remember, your computer may or may not be lying to you depending on the information that's coming in from the thermocouples. So what we've got to do is independently check each one of those Parisons and make sure they're within 2 or 3 degrees of each other. If they're not, then you need to go hunting and find out where the problem is. So once we've got the temperatures all the same, lock them in, do not change them. Now, every extrusion head that has multiple Parisons has a flow control valve on them. They're basically a screw in, screw out system, and it essentially chokes the flow of material going to that particular Parison from the extruder. Now, it's a very, very important point which I'm about to make, and this could make or break your machine. So I'm just going to focus on it just for 1 second. Always make sure one of these flow control valves is open. Never ever choke them all down. What you'll do is overload your extruder. So you've got to avoid choking and back pressure on the extruder by always making sure at least one of those flow controls is fully open. If you don't know how to do that, then refer to the original equipment manufacturer's manual and find out how you make sure one of those chokes is actually open. Okay, so where to from here? So we've covered off the Parison expansion into the mold. Now what happens if we've got a different temperature Parison here and same shape, it's going to expand differently in the mold, so you're going to get thick and thin sections. We're also going to cool at different rates. So that means that, and we're going to focus on a hot Parison, that means that you've got to run your machine at the cycle time that suits the hottest Parison. So you're going to be slowing down your machine, in this case, to suit one Parison, when in actual fact, if we were running correctly, these two Parisons, the temperatures are correct, and we'd be running okay. We could run at maximum speed. So thicker plastic takes longer to cool, therefore we're having to run our process to suit this overheated, out of control Parison, which is expanding to the mold incorrectly, which is creating thick and thin spots. Now the other one I just want to quickly touch on, a lot of food manufacturers are actually creating products with lost heads, and that's a bottle where we trim the top of the container off and that gets recycled. You know, a yogurt jar or something similar is a good example of that. Now the interesting thing about lightweight lost head products, or lightweight products in particular, is that you'll get different brimfuls, you'll get different dimensions. So the molds might be exactly the same, your water cooling in your molds might be perfect, but if you've got different Parison temperatures, you're going to get different dimensional results. because the hotter plastic takes longer to cool, therefore it shrinks more. So again, I've got to come back to saying make sure each of these temperatures are within 2 or 3 degrees of each other. Otherwise, we will get variations in your bottle dimensions. Okay. Some basic rules to live by. Always work with facts and data. So your machines are trying to tell you a story. Make sure you get your gauges in place. Make sure you get your independent readings and check those. Make sure everything is working correctly. If it's not, make sure you jump right on and get it fixed straight away. Question anything you're not sure of. If you're not sure of what the temperature should be, go and find out. If you're not sure what the correct ratio of regrind going into your into your Parison is, go and find out. If you're not sure, make sure you go and question it. Now, pressure is a result of resistance to flow. We spent quite a bit of time talking about this in Module 1, and it's no different here. So if we think about our flow controls on our extrusion head, if we choke all those down, then we end up creating more pressure because there is a resistance to flow and we can damage our machines. And that's why it's so important to make sure we always have at least one flow control valve fully open. Know what your inputs are to get a predictable result. So make sure that you've got your water sorted, your temperature sorted, they're in control. If we do all that, then we've got a predictable result. We're going to cover off air pressure in the next lesson as well. So they're the big ones, they're the big ticket items: water temperature, water pressure, Parison melt temperature, and air pressure. If we've got all those in control, then our process becomes very, very predictable. Know and measure what your variables are. So what are your variables in the process? What are some of the things that you don't look at that you do make adjustments to? Understand what your variables are, measure them, then you can control them. And the last one is never trust a computer. Your computer is well, let's say they're not very intelligent in one way, and that is the information that's coming in is the only information they can use. So therefore they may generate poor quality information going out to your machine components. That's all for this lesson. So as always, make sure you go and use this information. Go and get an independent test process or a laser temperature controller. Measure your Parisons, particularly if you're running machines with individual Parisons. Make sure they're all the same. All of these things contribute to an optimized extrusion blow molding process package. If you don't have them, then your process is out of control. So I hope you enjoyed this lesson. Don't forget to tell your friends about us, and look forward to seeing you again on Module 3.